This video is a review of solving quadratic equations. Quadratic equations are equations in which the highest exponent on a variable is 2. So as you can see here, 2 is the highest exponent on the variable x. Quadratic equations are often solved in a different way than linear equations. You usually can't get the variable by itself. Sometimes for simple ones like number 18, it's possible. But for 17, we don't have that option. So we have several other options. We could solve by graphing. I'm not going to do that in this video. We can solve by factoring, if it's a factorable expression. We can solve by completing the square, something I also won't do in this video. And we can solve by using the quadratic formula, and I'll do that. So for number 17, I give you a hint. I ask you to set it equal to 0 and then factor. That's one thing you'll notice when solving quadratic equations is unless they're one of the simple types, like 18 and 19, you set them equal to 0. And that's actually necessary in order to use the factoring method or the quadratic formula. So let's do that. We subtract 3 from both sides, and we're left with 6x squared plus 7x minus 3 equals 0. This is a quadratic trinomial. The leading coefficient is not 1, so the product number, as I've been referring to it, is 6 times negative 3, or negative 18. And the sum is the middle coefficient, 7. Now we need to find two numbers that multiply to be negative 18 and add up to 7. Notice that this is negative, so one of the numbers must be negative and the other must be positive. Because this is positive, it means that the larger number is the positive one. So 9 and 2, the 9 will be positive and the 2 will be negative. Then, if you like to use Knobe's method, you set up the two fractions with the leading term, the quadratic term, and you remove the square, or the 2 exponent, and you place the numbers that you found underneath those, and you reduce if possible. So this one, we can divide the 6 and the 9 by 3 to get 2/3, or 2x over 3. And this one, we can take a 2 out of 6 to make it 3, so 3x over minus 1. This tells us what to write in the sets of parentheses. So now this equation here can be rewritten as the quantity 2x plus 3, I'm getting that from this fraction, times the quantity 3x minus 1, and it's still set equal to 0. Now we can use the zero product property to solve. The zero product property states that any number times 0 is 0. That's significant here because it allows us to focus on one factor at a time. So in this case, the entire thing in the parentheses is a factor. If I determine what value of x makes 2x plus 3 equal to 0, it doesn't matter what's happening in this factor. This could be a trillion. And when I multiply it times 0, it's still 0, which satisfies the equation. So when we set 2x plus 3 equal to 0, we get 2x equals negative 3, and x equals negative 3 over 2, or negative 1.5. And then for the other factor, set that equal to 0, add 1 to both sides, and divide by 3. Quadratic equations normally have two solutions. It corresponds to the fact that the highest exponent on the variable is 2. So what will satisfy the original quadratic equation are negative 3/2 and positive 1/3. And algebra gives us the power to find the answers quickly as opposed to guessing. Number 18 is much simpler. You don't have a linear term, meaning a term with an exponent of 1 on the variable. This one is also nicely set up. When you have on one side the totality of something squared, then you can simply take the square root of both sides to remove that square. Just keep in mind that you need to add the plus or minus to the other side. That's because the negative version, when squared, becomes positive. So the values of x that work here are either the positive square root of 17, also known as the principal root, and the negative square root of 17. So two answers. And if this was an application, we would find a decimal approximation of 17. For example, if we were building something, and maybe we would get 4.1, let's say, feet of material. But this is staying in the realm of theoretical mathematics, so we'll leave it in this exact form. And this radical cannot be simplified further because there are no perfect square factors in 17. Number 19, notice that you have something in its totality being squared on one side. That means you can take advantage of the square root property and square root both sides, keeping in mind to add the plus or minus on the other side. This square root eliminates this square, their inverse operations. So you have what's in the parentheses equal to either the positive or negative square root of 12. Now, we want to get x by itself. So I add 4 to both sides. So we get that x can be 4 plus or minus the square root of 12. Next, we want to leave it as a simplified answer. 12, or the square root of 12, can be simplified further because 12 has a perfect square factor in it. 4. So this is equivalent to plus or minus the square root of 4 times 3 as the radicand. The reason I wrote that is just so that you can see, if you didn't know, why this works, why this simplification works. The reason is because there's something called the product property of square roots, which says that if you have the square root of a product, you can express that as the product of the square roots of the factors. And the square root of 4 is 2. So this becomes 4 plus or minus 2 times the square root of 3. Those are the two values of x that make this statement true. As I wrote here, there's no need to FOIL or expand this binomial. You could, but it would just add more steps. Number 20. I give you a hint. Use the quadratic formula. That means that we need to set this equal to 0. So I add 2. This cannot be factored. There are no two numbers that multiply to be 2 and add to negative 4. The quadratic formula, I would commit it to memory. It's not too bad. Negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 1. It's the coefficient of the quadratic term. b is negative 4. And c is 2. Now it's just using the formula and doing some simplification. So x equals the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2. And that square root divide by 2 times 1. This becomes positive 4. Underneath the square root, this becomes 16, and then minus 8 all over 2. Further simplification makes the square root of 8. Then we can simplify the square root of 8 using a process similar to what I did with the square root of 12. And that will be 2 times the square root of 2, because it's the square root of 4 times 2, and the square root of 4 is 2. Still over 2. And notice that we have a common factor of 2 on for all terms on top and bottom. So we can remove that. So this expression simplifies to 2 plus or minus the square root of 2. Those are the two values of x that make this equation true or balanced.